So, has anyone heard about classes? I'm sure that you have used classes before in JavaScript, but let's use this time to kind of reiterate what those are. Yeah, Dustin, you're in a class right now for sure. Not this kind of class though. Um, more like the. Actually, you can say that this class is a kind of a type of class. Um, yeah, Yasir kind of right. JS classes are a bit syntactic sugar, kind of like wrappers around objects, but they kind of do the same thing anyways. It's a fine line between syntactic sugar and actual implementation. Yeah, Rain, that's a good example of classes. So person, place, thing. So in general, like nouns. Um, I like Steve's idea of blueprint for props and methods. Yeah. Um, and Gayathri said mimics real world entities. Yeah, it definitely can. So I'm going to go with Steve's idea first in explaining what classes are. So classes represent blueprints kind of what Rain said, person, place, thing, whatever it is. So blueprints for it's hard to describe kind of a catch-all phrase, but blueprints for things maybe. This could be some kind of concept like an actual mapping to, like, let's say an animal or some kind of other object. It could be some kind of concept in your application. So maybe it could be like a string parser or another data structure. For example, in Python, arrays are essentially classes as well of an object that describes kind of a sequential set of items, numbers, objects, whatever it is. A dictionary is kind of a class that describes an object that maps from a key to a value. They are essentially classes as well. So they're blueprints for things. So essentially, classes are blueprints and instances of classes. When we do something like new class, when we actually call that, that's an actual instance. So what is the difference between an instance and a class? Can anyone tell me? Yeah. So Ronnie's right. So like I said, the important part is that classes are blueprints or templates, and when we actually create an instance of the class, we fill the template with maybe some sort of variables, um, like Steve said, props, for example. You might pass in certain variables to that class to create an instance of it. So let's take an example of a class, for example. So let's take animal. So if we want to create a generic class that describes an animal, and if you think about it, there's many different types of animals that we could create. We can create a dog, a sheep, a mouse, many different things that you can call those instances. But all animals would have certain properties, certain attributes that they would all share. What's an example of an attribute that they might share? Yeah, so they might have a certain lifespan, eyes, maybe like eye color or something like that. I would say maybe size too. Yeah, all of those are awesome for sure. And actually, Rain and Dustin, you guys are. I agree with sound. That's true. So, what kind of sound does an animal make? But besides attributes, animals can also do stuff, right? They also have certain kind of verbs, certain things that they're able to do. Um, and we could describe those as essentially the methods on the class, the different functions that a class might have. So in a way, Dustin animate, I guess, would be a function, and it might do a certain thing, functions. Most animals make some kind of noise, I would say. So maybe there is some kind of like, what is the like make sound, for example? Make sound. And so then they might look the specific animal, every animal makes a different sound. So they might look at the specific attribute that they have. So if a sound is a sheep noise or a bark or a meow, they might make the appropriate sound based on the attribute that they have. And so what are instances of animals in that case? Right. So instances of animal might be a cat, and a cat might have, let's say lifespan, eye size, sound, they're all kind of in the order. Maybe they live up to 20 years. Eyes might be yellow. Size, I don't know, we could say small or medium or something. And sound is a meow. Meow. 9 lives, yeah. Definitely 20 times 9. Yeah, a bear. I don't know how long a bear lives, but I'm pretty sure it's more than a cat. What is it, like 60 years? Maybe brown eyes, large, and they just roar. I don't even know if there's an official bear noise. Right. So pardon my writing, but essentially we have a animal, and this class kind of describes a blueprint for a specific animal. And then we could actually go ahead and instantiate different items. So a cat, a bear, and they might all borrow all of the work we define an animal, and also basically have all of these properties defined. You can add multiple classes in the sense that you could, an animal might have a different, maybe an attribute is another class, for example. Christian, is that what you're kind of hinting at? Because we are definitely going to talk about how classes relate to each other and how they work with each other. So I'll talk about that in a second. But so can anyone see kind of a clear advantage when it comes to maybe code organization that we get from creating a class and then having these instances? Like why bother? Yeah, dry, rain. What does dry mean? Yeah, don't repeat yourself. Yeah, Steve's right. We can reuse these, right? So let's say we want to now say, okay, well, animals make sound, but then they also maybe they go to sleep or they eat or something. Maybe they eat a specific type of food. We know we don't have to go and define an eat function for cat and eat function for bear. We can just go ahead and define that in the animal class, and then they all immediately get that function available to them. And just like that, if there is a bug, we could track that down to the root cause, which might be just one function in an animal, and that might solve a bug for basically all of the instances of cat and bear and whatnot. So we don't have to go ahead and define all of these different attributes. And if we ever want to refactor or extend this, it becomes quite a bit easier. So we can definitely see the big advantage there. Um, and with this, it's clearly an advantage, but there is a bit of a gotcha, because the challenge with object-oriented programming then becomes, how do I effectively break down my problem into these small chunks? That's kind of where the programming challenge ends up becoming. So, and it's hard to say what the real answer for that is. Oftentimes it's, oftentimes you might think that you have a right idea, and then you might notice that one class becomes too big. And then maybe if that class is becoming too big, maybe there's a base class you can extract that into or something like that. The answer is going to be ambiguous, because with software, we end up having to be a little bit creative. But in general, that's kind of where the big fun challenge of designing programs in object-oriented programming is what is a reasonable kind of logical break between different classes. So animal, yeah, exactly. So like, well, John, what if I have a robot animal that is different from normal animals? Yeah, I mean, maybe that might be like a subclass of animal. We could talk a little bit about that. Or maybe at first you can just add it as a parameter, just say robot is true or false, true, false. But maybe maybe you want to have very specific functions for robot, and that ends up polluting the animal class a lot. So that's a good example of trade-offs that you can make in this case. But yeah, so that's kind of what I wanted to say. Is that's where definitely most of the big thinking is with object-oriented programming. Okay, so this is a very brief introduction of what a class is and what instances of classes are. Let's talk a little bit about how classes relate to each other, and then we're going to go into coding this up and seeing what the syntax and kind of how this works in Python. And we're definitely going to, the goal for today is for us to kind of learn how classes work in Python, get used to the syntax, and kind of see a couple of relationships. And then on Wednesday, we're going to explore class relationships a little bit more, but I'm just going to do a quick, brief little overview of it. So I actually kind of like this example of an animal, maybe a robot animal. So let's start with animal first, right? So we've kind of already established what the animal class is. We've given it some attributes. I'll call those adders, and we have some methods. But now let's say we want to create a subclass of animals, and let's call it like Android animal or something like that, and they'll have different different functions, but they will obviously still have eyes, and they'll be able to make sound, and they'll be able to do everything an animal does. So what we could do in this case is, instead of just recreating all of the attributes and methods and everything like that, we could do something called inheritance, where we inherit all of the attributes and methods from our parent. So in a way, we could say we inherit from animal. So we get all of the attributes. So we get all the attributes, all the methods, and then we're able to add on more things. So what would be kind of like another attribute on top of Android animal, or a different method? We might say that the sound is different. So maybe we can overwrite the make noise, make sound, and we could take the attribute for sound and maybe make it metallic or something like that. So we could overwrite it, but we could also add a bunch of other different properties. Lifespan might not be quite as relevant anymore, maybe like power level or something like that. But essentially, this gives us the opportunity to create a subclass, like a child class, from a base class very quickly by taking all the attributes and methods and extending to a few more. So let's say maybe color, because maybe you can have like a metal color or something. We're not starting any Android versus iOS flame wars in the chat. Cool. Yeah, maybe version or something. There's another way that classes can relate to each other. So this is the inheritance way, where one class becomes a child of another class, and sort of we can call it a superclass, because it essentially takes all the properties of the previous class and adds more to it. But another thing that we could do is one class can have other classes in it, and we're going to take a look at an example today, and that is not called inheritance. That is called composition. So an Android animal might have, I don't know, let's say that we created this Android animal for peacekeeping. So it might have some kind of, I don't want to go with weapons. Maybe it could have some sort of cool add-ons or something. Let's say that instead. And so maybe this is an array of stuff. And so maybe an Android animal can have like a jetpack. And jetpack could be an instance of another class. So we can have a class have attributes that link to other classes. And we sort of compose an Android animal. So an Android animal can be kind of like an animal, as well as it can have other classes in its attributes. If you think of React, when we create React classes, essentially a class in React is a description of a component, and an instance of it is when we actually use it in our render function within our app. Say we have a button class, and we might have a color attribute on it. We don't have to recreate the button and all of its HTML everywhere we want to use it. We just create a new instance of a button and maybe define the color attribute. But in React, what do we do when we create new instances or other classes? Do we use inheritance or composition? We use super, but think about what you extend. When you create a class, you extend from the React component, and that's pretty much it, right? We've never really extended from other React components. So yeah, there is inheritance. I apologize, maybe this example wasn't the best to bring up, because there definitely is inheritance. But when you're actually creating a component and you have a button in there, or maybe like a text field or some more UI elements, are you inheriting or are you composing in that case? Yeah. So in React, the way you create other components is almost always through composing. In fact, actually, React has specific guidelines saying don't inherit. Once again, notwithstanding the fact that we have to inherit from the React component class. It's the one exception. Maybe that wasn't the best example to bring up, but essentially the idea is that the relationship between two composed components, or sorry, two composed classes, is one where one component has other components in it. It's not just another version of a class. It specifically has another component or another class inside it. Okay, cool. Yeah, maybe HRCs are a bit of a different situation too. I want to move on from the React component example. I think that might not have been the the greatest one to bring up. But okay, any questions about this so far? Otherwise, let's take a look at how we actually implement classes in Python. Okay, if there's no more questions, I'd like to move on to an actual coding example. So let's go ahead and do that. Just clear this board. And let's do this. Okay, cool. So we have a task. We want to create a app, kind of a terminal input app that allows us to kind of create a glossary or a directory of a department store. So we want to be able to create a store and then maybe explore different departments and kind of see what those departments are about. So the first class that we want to create is kind of expectantly a store class. So in Python, to declare a new class, all we have to do is just type in the class. uh, method and go ahead and name it whatever we want. So now we're inside the scope of the class, and we can define the attributes and the methods that a store might have in our case. So the first function that we're almost always going to want to start with is the constructor function. So if you remember in JavaScript, when you would create like a React component, you would have a constructor, and there you might declare a state or other sort of attributes of the component. Here, we're going to want to do a very similar thing, but it's not called a constructor in Python. It is called init. And take a look at this notation real quick. It's got these two underscores, and that's not by accident. These underscores are kind of this underscore underscore init underscore underscore is like a reserved method for a store. Oh, sorry, for a class. And anytime we create a new instance of a class, it's going to immediately call this init function or this constructor. Dustin, I don't think that we can leave it at this. I think that we must declare it with two underscores. So this whole thing is basically expected by Python that you create one of these. In fact, actually, we can see what happens if we don't. I think we might actually not be able to use this class. So it's essentially, you have to at least have this function to have a working class. And the first parameter here is always going to be self. So basically, we have now a working class. So pass in this case is just a word that says continue or whatnot. And let's talk a little bit about this self parameter. Anyone already have maybe a guess as to what this self parameter might be? Yeah, okay, so some people are already seeing the connection. Self is essentially this. So Dustin, you said the class, but actually, it's not really the class in this case. It's going to, what would it actually refer to? So let's say I made, let's say I instantiated a, let's call a store dugout. So, or let's call it like sports store actually. And I will create a new store. This self, what will it be referring to if I were to maybe print self or something like that? Yeah, so this self is going to be the individual instance of the class. Definitely. So essentially, the very similar to how this keyword works in JavaScript. Yeah. So it's not going to refer just to store. It's going to refer specifically to sports store. Okay, but so far this class is pretty boring. It doesn't have any sort of attributes or anything to it. So maybe let's add a couple of properties to it. Anyone have any ideas? I think name is a good one. Size is probably pretty good. I think, you know what, we're probably going to want to have like a list of departments. Let's call them categories. Yeah, and maybe we could do like address or something, and maybe we could have it optional or something like that. Liquor license. Yeah, definitely good. All good. Maybe we can add liquor license to a specific restaurant type of store later or something. Established date. Yeah, that's not bad. Maybe we can add that. We can make that one optional as well. We definitely want a name. I can't think of a single store that doesn't have a name, even if it's one of those no-name stores. Still find it somehow. And categories, we can make that an empty array for now. Cool. So let's create a sports store, and the departments might be different sports. Anyone have a name for a sports store that we could use? Justin's Academy. Frisbee Unlimited, Frisbee and Beyond, Lamb Dugout. I like that one. Lambda Sports. That was not quite original. In my notes, I have the dugout. If anyone wants to go with that one, but oh yeah, sure, okay. I think I can actually, let me see. I think there's a way I can actually input emojis in here. All right, let's just call this, let's just call it Lambda Sports for now. Cool. So now we have Lambda Sports. Maybe we can do categories already as well. Let's just make them a list. Maybe we could do like running, basketball, baseball. Cool. And now what we could do is now in this init function, we can assign different attribute names to these values. And so what we could do is we can use that self variable that we have passed implicitly as the first parameter. And I can explain that because as you can see here, there is no self. We kind of skip it and just go straight to name. I'll explain what's happening there in a second. But essentially, we can now do something like self.name equals name, and maybe self.categories equals categories. And we can finish the rest, self.address equals address, self.established equals established. So now the store has a couple of more interesting things, and we can actually maybe, I don't know, go ahead and print, could get rid of this pass, and maybe we could do something like print sports store.name and see what happens. Read, can you just pass self and adders on line 2? And so self.adders.name. Yeah, I guess you could. You could do something like adders, like attributes, basically. You can unpack it. And then you could do like, not sure. I mean, maybe. Yeah, I mean, technically, it's just like a function the same way you would do. Yeah, you could do like, yeah, better to do the kwargs. I'm actually not fully sure what kwargs supposed to stand for. Key named arguments. We could use those as well, for sure. In fact, there's probably a lot of built-in classes and things like that that end up using that kind of thing. I mean, I say it's pretty simple to just go ahead and use a couple of name parameters. So, but we definitely, it's just the same as any other function in that case. Okay, let me run this real quick and see, hopefully that this, this works for me. And we should be able to see Lambda Sports as the name. And we could do categories. We could print that, and that'll work. But let's actually do something a little bit more cool. What happens if I want to do print sports store? That would be pretty sweet if I could be able to do that. But we kind of get just sort of a very uninteresting object reference. I don't really know how to interpret that. I guess it says it's a store and it's an object and this some kind of random number. I'm not sure. But I mean, if you think about it, an array or a string or other sort of built-in data structures, they're actually classes as well. And if I have an array, I can just print the array pretty easily. So how can I make it so that prints sports store works? And there's actually a couple of more built-in functions that we could define that help us out in this case. The first one that I would like to define is underscore underscore stir underscore underscore, and you guys already beat me to it. What is, anyone have an idea of what the first parameter I'd have to pass in here, or do I even need a parameter? Yeah, you guys are on top of this. Self, for sure. Oh yeah, and I wanted to explain this self for a second. So essentially all class methods will implicitly have the instance passed in as the first parameter. That's actually pretty much all there is to know. It might be kind of confusing sometimes because definitely it's very easy to forget to add self as the first parameter, and definitely easy to forget that the class will always automatically pass the instance into it as the first parameter. But it's just something that takes getting used to, but you will always be able to use self uh, right away as the first param, and then you can go ahead and define whatever parameters you want. Do you need self to use attributes in methods? Yeah. So if we want to access any of these attributes we defined here, we are going to want to call them self.name, because otherwise name doesn't actually exist in the scope. We'd have to maybe define it as something else. It'll just be treated as just a regular variable inside a function. So let's take a look at what stir does. Let's return I am a string first, and let's now call print sports store and see what happens. Cool. So it actually printed out I am a string. And actually, what print is doing is it's actually calling stir on the class, which in turn will call the instances underscore stir underscore method. We can call these magic methods to give it a kind of a cooler name. When there's two underscores, they're essentially built-in kind of magic methods. And so the reason why an array can print in a cool way is because somewhere in the depths of Python, wherever the array class is created, there is a stir function that that is defined to print open square bracket every value and other way. Cool. Okay, so this isn't exactly. I didn't disappear just now, did I? Because my computer just flashed on me for some reason. Okay. Oh, okay. They're also called dunder methods. You see? I didn't know that. That's pretty cool. I guess double underscore maybe. Yeah, cool. I didn't. I was googling to figure out what they were called because I was getting a dry mouth saying underscore nonstop. So, okay, cool. Thank you for sharing that. Cool. So, there's actually a couple of these magic methods, and so we have the stir. We also have another one called repr. And does anyone know what repr is? Has anyone heard of the difference? Yeah. Yeah, for sure. It gives you so repr is very much similar to string. You could are expected to return another string here, but repr is used to essentially provide a very kind of not flashy, just very matter of fact explanation of your instance of this class to maybe help developers debug. Or maybe have kind of a literal representation of your object, maybe so that a developer can literally copy that code and run it and see what is expected. So here, stir, we might say, let's make stir a little bit nicer. Let's return an f string where we say, welcome to, and we can do self.name. And here we could say something not fancy at all. We could literally make maybe another f string, and we could just define what the parameters were that got called to make this object happen. And so when someone is looking at your object and they're wondering why is it that the name is that way, they could see, oh, it was called kind of like this. Or maybe you could be even more descriptive. You can say the parameter self.name is this, something, the category is this. So essentially, it's to help the developers get more context on your class. So right now, if we print stir sports store, we'll get welcome to Lambda Sports. So that's kind of expected. If we want to print just a string representation, we should receive some kind of user-friendly, nice message. But if we go ahead and type in repr, then maybe I'm a developer who wants to debug, and I can type that in, and I can see, oh, okay, so it was called exactly like this, or something like that. Or I can even add, this was called as, yeah. So it's always good to have both of these in mind. Stir, definitely a great way to kind of give a nice clean output of your instance. And in this case, this is going to be useful because we want to create a nice app that says, welcome to the store. Here are categories. Would you like to learn more? So I think let's, I'm going to pause for some more questions. Does anyone have any more questions on this? Yeah, so difference between, so once again, a difference between string and repr. They basically look like they're doing exactly the same thing. It's really more who is calling it and who's expected to call it. So if you're a developer and you're using a class that someone from somewhere gave to you and you don't know how it works, you just import it from some module, then you might want to call repr sports store to basically get an idea of, okay, what is going on with this class. So if I'm not quite sure how to how to use this, maybe repr is something that might help me. It might not even be defined, to be fair. So Justin, you said, would you always want a repr in each class? I mean, it's kind of up to you. Maybe the class isn't that complicated. But yeah, it kind of acts like inline documentation. Yeah, okay. So Reed, it's a good call out. Maybe this isn't the greatest message to give out. That's definitely something to think about. I'm just showing an example of what you might output as repr. I saw when I was, I want to give you an example of what an actual Python example from an actual library does. So if you check this out, let's down here, import built-in module that Python has called datetime. So it's something that is used to represent dates. And if I do today equals datetime dot now. So here I'm going to create a instance of a class called date. And I could go ahead and print the stir of today, or I could print out the repr, and let's take a look at what the developers of datetime decided is enough information. Cool. So here's the current date written in kind of like a human readable form. Give us all the way down to, I don't even know what microsecond that is. But here is kind of the implementation of this specific instance. So here, if I were to call this in a Python interpreter, you might see, so this is kind of like, how did we get this result? Oh, okay, it was called as a kind of an instance of this class. Yusir has a good point. So it's kind of like, It's kind of like developer specific and maybe your team specific. Some teams might want to have very documented repr functions. Some people might not even know they exist, and it's up to you to tell them. And then all of a sudden, you can add better documentation to your code. Uh, it's uh, it's kind of up to you, but I definitely want you guys to know that there are these two options for us to use. Cool. I'm going to delete this example. And one last thing I wanted to mention about this before we take a quick little break is take a look at the notation of how I defined the class. You always want to define a class with a capital letter. So you want to do a capital case. If you have kind of a two-word class, you will still want to define that as sports and then capital store. You don't want to have underscores in your class, unlike variables in Python. So that's kind of the does it work in lowercase? I actually don't know. I mean, it should, I guess, but it's you're going to, yeah, it definitely works, but you're going to get yelled at by either your pip or your linter in Python or every developer because you're going against kind of sacred convention of Python. So you definitely want to make sure your classes are defined with capitals. Okay, cool. So let's kind of reiterate what we just went over. Here we defined a class, which is called store. We defined a constructor, and in the constructor, we're able to pass the parameters that we want to initiate the instance of this store with. And we decided on 4, but there really is no limit to how many we want. And here we have an example of us calling an instance of a store where we pass a name and specific categories. So if we wanted to create another department store, if we want to do a grocery store or something, it would be very simple for us. All we would have to do is just create another instance, call it something else, and add some different categories, and it would be kind of very trivial for us. We would already get the string function with it, as well as these parameters built in. So let's take a quick 5-minute break. And after the break, we'll create a little input loop where we could ask the program about different departments, and we could actually add another class into categories and make it a little bit more interesting of a store experience. So I'm gonna put up a 5-minute timer, and I will see everyone in just under 5 minutes. If anyone has any questions in the meantime, feel free to ask. My favorite hobby. I really love cycling, but unfortunately it's gotten a little cold now, but it's not cold enough to go skiing yet. So I'm kind of just sitting inside these days. I'm in Toronto. Actually, Steve, I have been looking at fat tire bikes, but by this point it would just be so many bikes in my place. I have heard of Zwift. I look at Zwift like every other day, thinking I should go get myself one of those trainers, indoor trainers. So I might end up in that. Yeah, Toronto did get a lot of snow. Way too much snow for the beginning of November. Very unexpected, kind of cool because I like the beginning of winter. I like snow at first until it gets a little too tiring. Um, but yeah, the slope ski hills aren't quite open yet. But maybe I'll get a fat tire bike to cruise down the streets. Well, skiing in the winter, that would be nice. I personally like skiing. I've been skiing kind of all my life. Snowboarding still troubles me a lot. And yeah, Sean, that's true. The snow will definitely be here until May. So uh, it's it's the lovely Canadian life. Well, and I don't know how you guys do it with your feet tied to themselves to each other. At least with skiing, you can sort of gently slow yourself down and just lay down on every time I tried snowboarding, I always feel like I ended up flying. Okay, cool. Ooh, Wilfred, I should check that out. I've been to one spin class. It's brutally hard. Thank you for that link. Cool. Okay. Let's get right back into this. So, like I said, our goal here is to create a application where we could go ahead and ask, hey, what store is this, and kind of what are the categories, or maybe ask a couple of questions to it. So at this point, let's take a quick little break from creating these classes, and let's actually create a REPL. And what REPL stands for is it's a loop where we read, evaluate, print, and then loop. So it's called REPL. It's kind of language agnostic, but it's kind of how all command line applications have always worked. If you think about it, you read some sort of input from the user, you then evaluate and kind of interpret that input. You print out something, whether it be what the user expected or maybe some kind of error, and then you loop and start it all over again. If you've noticed, a lot of applications, they don't terminate right away in a command line setting. They might terminate right away, and that might be what the evaluate and print loop part decides to do. But otherwise, we might end up looping. Let's do the read part first. And so you guys have already possibly seen how to do this in Python, but let's go ahead and add that code in. So let's say selection, we're going to store what the user writes in this variable called selection. And to get input from the user, all we need is this input keyword, and then we could pass in some kind of guiding message. So select the number of a department. And then we could print the user selected, make this a format string. Oops. Selection. So if we run this, we could take a look at what's going to happen. Let me clear this and run. Select the number of a department. As you can see, my application didn't end on me yet, so I can put in 2, for example, and it'll say the user selected 2. So we've sort of handled the read and part of the print. We need to add an evaluate loop. And so what I'm thinking is it would be cool if we could print first kind of all of the sports store and maybe all of the categories or departments, and we could then have the user select one and maybe get some more details on that specific category. So at first, let's go and expand on this string dunder function. And let's have it return kind of like a wall of text that welcomes us to the store and maybe lists off all the departments in the store. So for us, the stir method expects us to return a string. And so for us to kind of have this multi-line string, it's easiest for us to start with an empty one and kind of build it and return it all at once. So let's just do that. Let's create an empty string. And the first thing we can put in it is welcome to, let's make it a format string once again, self.name. And I'm going to do /n. And what this /n does is it indicates that this is a new line. So when the terminal will print this string, it will kind of add a new line character, which will then push all of the code or all of the output down one character. Let's go ahead and create a loop. So for category in self.categories, we could go ahead and let's do this. Is anyone familiar with the enumerate method? So what I'm trying to do here is I would love for the output to look something like this. 1.running, 2.basketball. Right, so I could add a counter kind of out here and start it at 1 and basically just add it. But what enumerate will do is it will basically add a 0 and a 1 and a 2 and a 3 to each of the categories, and it will create a tuple where the first value will be the index, you could say, or the count, and the second value of that tuple will be the category itself. So to give you kind of an example, let's try this right here. Print enumerate sports store categories. Take a look at what the output will be. Whoops, I have some syntax issues. Okay. Oh, I was kind of hoping it would actually output. I wonder if there's a string for it. This might not be as climactic as I was hoping it would be, but it's okay. I guess let's explain. Okay, that doesn't work. Essentially, it'll do this. Here, I'll show you. So if self.categories is running, run, basket, base, enumerate will turn this into an array where the first value is 0 and the second is run. Then it'll be 1, Bask, and then 2 base, and so on. So that's what enumerate does. And so we could go ahead and actually unpack that right here, and we could say number, comma, category. So we can access the first value, the 0 here, and then we could access the category like normal, because it's going to be the second value of this tuple. Justin, it's useful right now because now we have, essentially this is I. If you think about the way we do loops, we basically have access to I and the value right away. So there's, again, like I said, several ways that we could do this, but here I have a situation where I need both the value and sort of the I, the counter. So if you think about the way the several options that we have among us to do for loops, this is kind of one of them. Yeah, exactly. It is the index for sure. Basically, it's exactly the index. So it'll be 0, and the category at index 0 will be already available to us through the category. So if we did print I category, we could see what will happen if we print sports store. There we go. So we have 0 because the I will be this 0, and we have the value. We have 1 basketball, 2 baseball, and I don't mean to confuse anyone. I thought this is just a cool function that we can have in Python, but we can just as easily, instead of doing it this way, we could also just do I equals 0 and then for category in self.categories, or let's start I at 1 in this case. We can just go ahead and do it this way, where we just increment I every single time we go through the loop. So I'll stick to that one, but I'll kind of keep this comment here if anyone is interested in the enumerate method. Cool. So in this case, we are adding more to the output. And so let's make this another format string where the first value will be I dot, and then we could do category. And then let's add a new line as well so that it goes and prints all kind of on new lines. And let's go ahead and return output. So now if we print sports store, we should see a nice welcome sign. And it, oh, right, we forgot to do I plus equals 1. My bad. If we do that, there we go. We have 1, 2, and 3. So now when I uncomment this select, it makes a little bit more sense why we're asking for the number of the department. Cool. So now we can select the number of the department. We can do 1, 2, 3. We can say 3. The user selected 3. And now maybe we can give some more info on baseball. Any questions so far on this? Okay, cool. Hopefully it's the previous thing was straightforward. So let's go back to our REPL, so our read, evaluate, print loop. So like I said, we've got the read done. We've got the print kind of. We don't really have the evaluate yet. So in this case, we want to add some logic that then takes a look at the selection and maybe uses our sports store to give kind of a explanation of a department, maybe. So let's do something like, for now, let's just do something simple. The user selected, instead of saying selection, let's actually go ahead and say what the selection was. And since we only have the names of categories at the moment, all we really could do is just print out the category name. So in this case, pretty simply, we could just access the categories parameter and pass in the selection. So because the categories is on the self parameter of the sports store, we're able to access it much like this, much like how you're able to access properties on objects in JavaScript. So if we go ahead and run this, we have our options, and we can go ahead and select basketball, and it'll say, whoops, that didn't work. List indices must be integers or slices. Oh, right. We gotta turn that into an integer. And yes, good point. It will be off. So we should actually subtract -1. So let's try 1. Oh no. There we go. Now it should work. And as always, third time hopefully does it. Let's do basketball. And there we go. The user selected basketball, and we've quit our application. And Adam, that's a good question. What should we probably add to the evaluate to make this whole code a lot more secure? What's kind of what might happen if a user selects something we don't want? So right now we have this as our evaluate. Yeah, probably want some kind of error handling, right? Yeah, definitely. So there's a couple of errors that we might have. What kind of situations should we guard ourselves for? The first thing I think would be nice is let's just turn selection into a number right away. Yeah, so invalid department number, right? So out of bounds, definitely let's safeguard for out of bounds. So what we could do for that is if the selection is, let's say it's less than or equal to 0, or selection is greater or equal to the length of sports store dot categories. We probably want to print error, please enter a valid number. There we go. So that's one. And what will happen if someone just types in a bunch of characters? Let's see if we've done this right first. So let's try like 10. War selection greater or equal to. Oh, right, of course. We don't actually want this code to run, my bad. Else. So we did get that right error, but I forgot to actually not run the second line. So we definitely want to add for that. Another case that we have is if this part doesn't work, which means that the user didn't type in anything that could turn into a number. So instead of figuring out how we could deal with that, why don't we just do a try and catch? So what's nice is, well, let's first take a look at what the error will be. Let's say I type in a bunch of characters. We get this value error. So instead of writing an if statement or anything to capture this, we could go ahead and just use a try catch. Dad's sad, yeah. We could go ahead and just use a try catch. So much kind of like in JavaScript, we can add these statements that will try to execute, and if they throw an error, we could go ahead and try to catch them. So in Python, it's not called catch, it's going to be called accept. And we can specifically say what error we would like to accept, which in our case would be a value error. And so we could go ahead and we could say print error input was not a number. There we go. Cool. So now let's see what's going to happen. Let's type in a bunch of gibberish again. And awesome, our app doesn't crash. It goes correctly to the error, and it explains to the user quite effectively what the error was. So when we're creating user input, it's always very good to safeguard for all of the different possibilities that users will input for. So in our case, we only want a selection between numbers 0 and the store length. So that's kind of all that we're looking for. So in this case, let's double check that it does work still. We didn't accidentally lock ourselves out. And looks like we did, because, right. Because we're allowed to input that is greater than. There we go. So always good to double check all of my edge cases, and this should finally work. Great. If we type in 0, it will error out as well. Great. So now we basically have our read. We have our evaluate here. We've evaluated kind of all the different possibilities. We've added all the prints. The last step is we actually want to keep looping. So the first loop that we can kind of just do is a pretty basic while true. So this loop will essentially never terminate. So let's see what happens now. Basketball. I forgot to put the input into here. So the input should absolutely be inside of the loop, and that should terminate that. So let me do that one more time. Let's type in a number. User selected basketball, selected department, running, baseball, nothing, 23, nothing. And looks like we are on a good roll. Anything else missing from this program? Yeah, 2.5 is probably also going to break. Yeah, all right, great. How do we quit it, right? Right now, there is no way to quit unless I just terminate the application, throw an error for a keyboard interrupt. Terrible user experience. So we definitely want to add a couple more options to our loop. We probably want to have some kind of quit scenario. I think an easy quit would be if our code said, welcome to Land of Sports, choose one of these. We can do running, basketball, baseball, or a final fourth option to quit. So maybe we could say selection, let's set it to 0 here. Let's just set it to something. And while selection doesn't equal length of sports store dot categories +1, keep going ahead and looping. And what we could do is, if the selection is that, we could maybe give a nice message saying thank you for shopping, and end the program. So let's add that, print thank you for shopping, and the program, oops, selection. There we go. So we want to go ahead and kind of give them a nice message, and this should end all very nicely. Maybe we can add elifs in here instead. So this is like a else if in our case. Cool. So let's see what that does now. Yeah, Python, that would have been pretty cool to see if that switch. I've seen some interesting sort of switch solutions, but we don't need to go that. Okay, let's run this. And oh, right, we actually haven't added the option, but if we type in 4, it should quit. So that's pretty good. Yeah, we didn't actually add a print. Oh no, it did print that. Because if you think about it, here it's going to be 4. So this will turn into a number 4. It'll go into this if statement immediately. It'll skip these else's, and then when it goes back to evaluate the value of selection, it will be 4, and thus this loop will terminate. Yeah, and it's very important to have the input inside the loop, as we saw. Otherwise, you're going to end up with a basically infinite for loop and never ask for input again. But let's quickly add a final message, maybe to stir, or we can add it to wherever really. We can add it here, for example. Print. No, let's add it to store. I think this is a nice place right here to add it. Let's do output plus equals I exit. So at this point, the loop would have ran through all of the categories, and so it would be already +1. So it would automatically iterate to the next value that we need, which would be just 1 bigger than all the categories we have to offer. We add that to the output, and that should print us a exit message. So there we go. So if I press 4, we should exit successfully. Cool. So now we've added kind of all of the good parts, all of the mandatory parts of our REPL. We are reading right here. We're evaluating. So we have a couple of things going on here. We have several if statements for different types of input. And at every step, we're kind of evaluating and we're deciding what to print. Kind of print is essentially our output to the user as the command line application. Since we're writing that, that's essentially the update, sort of the view of our application. And we also have a try catch as well for some sort of, for certain situations. We added that because we have something that could crash given a specific input. So a try catch works well in that case. And finally, we put it all in a loop with some sort of ability for a user to set the variable that we're comparing to so that we could actually terminate this. Yeah, so at this point, I want to ask if anyone has questions. And Jordan, you said, can I scroll back to the top? Certainly, I could. I'm assuming you're referring to maybe this code here. Yeah. So once again, we want to return a string to be able to actually print. And we kind of construct this string out of several parts. We first have a welcome message with the new line, and that prints this. We have this for loop that starts by adding a counter and the name of the category and incrementing the counter. And finally, we also output an exit option. Okay, so any questions on any of this so far? So classes and REPL. And spoiler alert, in the project, which we will discuss at the end of the lecture for this week, you are going to need to implement your own REPL. So read, evaluate, print, and loop parser. And you're going to be creating an application with several classes that all have kind of a place in that evaluate loop. Don't worry, I think it'll be fun. Um, okay, so one thing that we're kind of missing from this is our department store output isn't really that great. It just tells us that we've selected running, basketball, baseball. It doesn't actually tell us anything about the categories. It doesn't say what running might have in it, or what basketball is about, or what baseball. So as far as an application design is concerned, this is kind of not great yet. So I think the final thing that we were going to do today is let's extend this application so that it outputs kind of some more meaningful information for every category that we might want to add. So let's think about categories. Right now, they're just an array of strings, and all they have is names. But what if we wanted to have a name of a category and maybe a description, or maybe even like a location, like a floor 2 or floor 5, something like that, right? What might we want to create? Yeah, Steve, we could create a dict, but to give away what we're talking about today, maybe that'll give you a hint. And Yasir is already on the money. We can create a class for a category, and we could add, so all categories, we could probably agree, should have a name as an attribute. They might also have a description. What else? Well, I said location already. And many different things. Now, a dict could also theoretically work, but why would creating a specific category class and maybe instead creating several categories here as a class be kind of easier for us long term? Um, well, no, not enumeration. So this is kind of an example of a software problem that we have to kind of now decide to solve in a way, right? And if we created these three categories as dictionaries, what happens when we want to add a fourth property? How many times would we have to? How many lines of code would we have to add if, let's say, we've gotten the name and description in the dictionary, and let's say now we have three categories, and we want to add to each of them a way to, I don't know, maybe some kind of method to print out the description or something like that, or do some kind of function, right? We kind of, we would have to basically go into every instance of that dict and kind of add new values to it. Whereas if we had it as a class, we could just go ahead and add some sort of functionality to that class, and all the categories everywhere in our application would then benefit from that. So let's go ahead and create a category. So here I have a different file, and in my tree, in my folder, they're both in the same place. So here I have category, here I have store, but let's focus on category for now, and let's create a new class for that. So once again, we want to go ahead and create that, and we always want to go ahead and start with an init class, pass in self, and let's say, again, for category, the first thing will be name, and maybe let's add some kind of description. And again, all we have to do is do self name, and self name equals name, and self dot description equals description. Maybe we can add location too, since it's kind of related to department. Most people are interested in where, what floor, for example, a certain department is located at. So maybe we can add that too. Cool. So now we can go ahead and import this category from this category file. We can import this class and use it here, much like we imported all of those built-in Python classes before in our first project. So because they're both in the same folder structure, importing them is actually pretty easy. All we have to do is from category, import category. And as you can see, my autocomplete already kind of did most of that. It already knew that there's a category Py kind of in the same folder structure. And I was able to import the one thing that the category file had, which was this base category class. And so now I could go ahead and instantiate it to my heart's content, just like I instantiated a store. So down here, where I have categories equals running, instead, I can go ahead and instantiate new categories. So let's actually create them as separate variables. So let's say this running category equals category, running, shoes, and so description for running, shoes and other gear. And the location, maybe let's say it is floor 2. Basketball. We could say oops and false. And we could say that's on floor 1. And baseball category. Once again, we could say bats and bases. And we could say that's on F3, floor 3, for example. And so now let's replace these categories with not with the strings, but with the actual instances of these classes. Let's add these on a new line, as this is going to become a little bit hard to read. Let's add them here. Cool. And this one, let's do baseball category. So now, instead of having strings in the array of categories, we now have this relationship where a store has many categories, and they're all instances of the category class. Now, if I run this right now, we've made some assumptions about these categories, about these arrays that are probably going, oh, yes, thank you, that are probably going to end up breaking our code. Because here we've just added category in here, and it's not going to kind of be super neat. It's going to, in fact, output the class now instead of just the string from before. So if we go ahead and run this, we could see that it outputs the categories. So we might want to do something a little bit neater here. So maybe in that case, how do I change this code to make it a little bit neater? How do I do it so that it outputs the names? Yeah, I want to do category.name. Thank you, Kadasha. Cool, because it's a class and we remember that we've created a parameter name on it, we can just go ahead and do that, and we should be back to normal. There we go, awesome. So because that was running, basketball, baseball, we now have the name. And let's say that for, well, okay, yeah, I'm getting a little ahead of myself, but yeah, great. So we're back to normal, and let's say that I want to select this. Obviously, this isn't, we didn't add the name to the other output that we have in the REPL part. So down here, where we said user selected this, instead, let's do something different here. Instead of the user selected blah, 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 let's have Sports Store print out the description. There's a couple of things we could do. We could do sports store.description, but we also could just go ahead and print the actual category. So let's not have our REPL decide how it's going to be printed. Let's just have category decide how it should be printed. So if we want this to work, yeah, what are we going to have to do to category? So let's see what we're at now. If I type in basketball, it's just printing out the object. So Yasira already answered the question, but what function do we want to add to category, the class, so that we can print this? Yeah, we want to add the stir. And here we have creative freedom to do whatever we want. We don't necessarily just have to print a description here. We can go ahead and print the name, description, location, and the category. That class decides how it's going to display itself. And with this, it gives a lot of the power and sort of a lot of the responsibility and abstracts it to the category. So once we're done with this, all we have to do is print it and know that the category class already knows how to display itself with the right information that we want. So we've essentially, if we, to kind of bring back another idea, if we made these dictionaries, then we would have to add that functionality to decide how we want to print it inside either the store class or maybe in our REPL. And we kind of delegate that to the class itself, where it kind of makes more sense for it to own sort of its own presentation style. So we could just have it return something like self.name. Let's add that into format string, self.name, self.description. And we could say, and it's located, or maybe we could say, let's add another /n. Let's make this output, and then output plus equals located on self.location. We want to make that a format string, and let's just return output. So here, pretty simple. All we would like it to do is output the name, the description, and where it's located. And because all of the parameters are available to us in here, we can just go ahead and add the logic here. And with kind of one location, we now have an ability to print each of these categories. So let's take a look at that. So here's where the printing action happens. If you recall, the categories is the array of all categories. So this will be one individual category. And once again, let's clear this. And let's select running. Awesome. So we already have running, the descriptions, where it's located, baseball, that, and double check that we can exit. Awesome. Okay. So let's quickly recap what we did to kind of quickly improve on this application, where before it was just outputting us kind of just a string of the name, because that's all the store knew, right? All we knew was just the name. That's all we were passing in. And now, because we're passing in an object, we're able to kind of instantiate, or an instance of a class, excuse me, we're able to create several different classes. And all we have to do is pass in the correct parameters. And because the class already knows how to print itself, it's able to go ahead and use the power of the fact that it's a category class to act accordingly when we want to print it. And this becomes a little bit, and obviously our application immediately becomes a lot nicer because we're providing some real value to the user. And we could have solved this in other ways. Certainly, we could have just turned running category into maybe a dictionary, and there we would do something like running or name running, something like that. And all we would have to do is create a proper print function that handles this object. But now that logic doesn't really belong. We have to stop and ask ourselves, does the logic sort of belong here? Because then we would have even more lines of code here. We're not quite sure why the code was added there. And this is sort of the prime opportunity for us to realize, oh, we have another kind of logical unit in our application. We have a category. We could go ahead and create a class and extract all of that logic there. And so now it is sort of neatly contained within this category class. And if we ever want to change this, it would be pretty easy. We know that we just have to access this class, and instead of located on, we might want to say, find me on this floor. Let's say we want to have a more whimsical message. All we have to do is change it here. And not only will this app benefit from it, but any app or anything where we use category will automatically benefit from this function. Whereas if we wrote a bespoke printing function in here, let's say we just wrote print category name, print description, we would then have to modify this, and maybe someone else who also has the similar logic will need to modify it there. Obviously, in this example, we only have kind of two places where we or one place where we need to print. But if we ever need to add that logic anywhere else, you can already imagine that it's going to become more and more convoluted and not very dry, as in we're going to be repeating ourselves a lot. Cool. So this is sort of where today's lecture is going to stop with in terms of content. And so let's do a quick little recap. We've discussed what a class is. So it's kind of like a blueprint of a logical unit of some kind of idea in our application. In our case, we decided to split this application into a store and categories. And there might be other classes we might want to add. And we're certainly going to think about those in the next guided project. The init function is our constructor, and we could add other methods that help us execute other specific functions that this class might want to perform. And we've also learned about these magic methods or dunder methods. In this case, we've learned about a dunder string and a dunder repr. There's also a lot of different dunder functions. There's dunder len, I think. And so if someone ever calls length on store, you might now be able to actually act on that. And you can also just add whatever functions you want. So I can't think of maybe like a close or something, where if you want to say the store is closed, you might do self.closed equals true or something like that. And you could now have a function on a class that any of your instances could then use. And we've also taken a look at how we can quickly create different classes to then sort of separate the units of logic from each other so that we could kind of clean this code up and not have everything live in kind of one location. And then we also learned about this REPL, this read, evaluate, print, and loop. The first step will always be to select an input, and we do that with the input keyword that Python provides. Then we want to do all kinds of evaluation, and we don't only want to evaluate the happy paths, the valid input. We also want to evaluate all possible input and act accordingly, because we don't want our application to be breaking all the time because people accidentally or maliciously input wrong information or wrong input. At any moment, we want to result in something being printed out. And finally, we want to go ahead and loop it with potentially some way to actually end the program. Okay, so I know we kind of covered quite a bit today. So any questions on classes, loops, Python, anything? And also I want to say that the page I linked at the beginning of us talking about Python as one of the helpful resources, the one that compares Python to JavaScript, will certainly have kind of a mapping of all of this class stuff to JavaScript as well, because there's definitely a mapping. JavaScript also has objects, which really are classes in a way. Oh yeah, Reed. So okay, yeah, good question. So Reed asked, when would you use the magic stir method versus just adding a method? So any time that you want your class to be able to be called by print or stir, you have to create the stir method. So this maps directly to, so see how we have print sports store on this line? What this is doing is it's doing this. Print is saying, get me the stir function of the instance. So it's literally just doing print sports store dot underscore underscore stir. So you'll also if you ever call stir sports store, right? So if we ever want to convert our instance to a string, the way that this stir and print know how to do that is they automatically look for this function. If it doesn't exist, it just defaults to printing out that kind of slightly ineligible or slightly illegible kind of output where it just gives you a bunch of weird Python stuff. But versus adding a method, I mean, we could have also just done something like this, sports store dot to string, and we could have defined, instead of calling this stir, we could have defined a toString method and have it all return. We could absolutely do that. So we don't actually need this. We could just call this toString, and we can call it here and it'll still work. It's just kind of a little too much when Python already gives you this this built-in sort of magic. Yeah. Yeah, and it'll only ever be the underscore underscore stir. If you ever want to manipulate these categories, or sorry, if you ever want to manipulate these things, these parameters, you might have to add functions. And we'll take a look at that both in the next lecture. You'll definitely want to maybe experiment with that in your assignment. And we can also go over more stuff like that in the instructor hour. Cool. Oh yeah, so Wilfred, you asked, when using try except, is except used strictly for error handling? Yeah, this is exactly the same as catch. So remember this, again, this JavaScript to Python cheat sheet, there's actually a section on except. You know what? I totally read this as except at first. There isn't. I take it back. I'll have to edit this. But there is a one on classes, so never mind. Hiding this. And yeah, so this is when we would do except. We could also do except error, I think. There is a default error that we could do, and it'll catch all errors. I just can't remember the name of the default base exception. I think it's just called base exception. Yeah. So this will catch every single error, but we're only interested in catching value error because that's the type of error that this line will throw. And as far as I can tell, we can't really throw any other errors here. So I didn't bother with just adding any other excepts. Cool. Okay, so if there's any more questions, please keep asking them. And in the meantime, I would like to go over the adventure game challenge. So let's take a look at this. So this is going to be the project this week. It's going to be a little bit more involved, but I think the end result is going to be kind of a lot more satisfying, a lot more interesting. I don't know how many of you have watched the What is an Adventure game, but has anyone played any classic kind of text adventure games in the past? Anyone kind of familiar with the concept? Yeah, tic-tac-toe is kind of, I wouldn't really call that an adventure game. It's kind of not really a ton of creativity and writing. Yeah, Nicholas, that's the attitude I like to see. Original Fallout, I don't know, does it count? I feel like original Fallout, didn't it have kind of like quite a bit of graphics to them? See, Oregon Trail, yeah. So Oregon Trail, you guys are kind of getting to the correct idea, but essentially, an adventure game isn't exactly very heavy on the graphics. Uh, and the input, and it's played essentially, yeah, it's like a choose your own path, choose your own adventure. It's essentially played all in a terminal, and it'll keep asking you for sort of like input. It'll give you kind of a description of where you are, maybe options to where to go and explore. Maybe you can find items or enemies or friends or anything like that to kind of encounter and do whatever you want. Yeah, I think Mud, right? That sounds super familiar. I think that's one. Yeah, there's a ton. The adventure games are essentially the first kind of games that were created on the computer. Basically, as soon as we had like a fully functioning terminal, people wanted to create games for them. So there's tons out there, and you guys get to contribute to that world by creating your own. So that sounds kind of like a lot, but what's going to happen is because we get to break down this problem into classes and sort of isolate all of the logic to individual classes, you might notice pretty quickly that the code becomes quite easy to work around. So let's take a look at the day one MVP. This is the first step. So your first thing is going to be to create a REPL command parser inside this file in adv.py, which allows the player to move to rooms in 4 cardinal locations. So let's take a look quickly at this adv.py in source, adv standing for adventure. There's already kind of a lot of code written for you. So you're going to have to first take a look at the code and sort of get past it all. But we already see that we have a class being imported, room, and we see this room object or room dictionary where I hope this doesn't end up causing any issues. Pretty sure it shouldn't. But yeah, here you have an array or a dictionary where if you do the outside room, you will get an instance of a room class where there is a name and maybe a description of what's in the room. So again, another name for a foyer, and you have the description. So think about how we just implemented a category. This would be kind of very similar here. They've already linked a bunch of rooms together. So a room will actually have a couple of parameters or attributes that they decided not to have in the init function. As you can see, they are not being passed around in here. they are added in kind of after. So the outside links to the foyer links to outside. That kind of makes a lot of sense. But who knows, maybe you want to have only one-way doors. That could totally happen. Overlook goes to foyer, narrow goes to foyer, et cetera, et cetera. And down here is where you would add your REPL, and you have kind of a couple of instructions already. One thing that's missing from here is no player. So that might be something that you might want to think about adding as a class. Maybe a player might hold some sort of information, specifically maybe what room they're in. Depends on where you want to take your game. You might want to give them a backpack, or maybe, I don't know, certain attributes, description of the player. Maybe you let people choose their own kind of appearance, something like that. And essentially, that's what you can do in player and room.py. So the first step is to just create the REPL command parser and to also fill out the player and room classes. So as you saw, the player didn't really have anything. It's up to you to decide what does a player want to have. They already kind of give you a hint that for sure you want to keep track of what room you're in. And if we take a look at room, also not really anything in it, but we should definitely have a name and a description. And who knows, maybe you want to add something else to the room. But for day one, that's kind of the goal. And if you take a look at day two, there's quite a few more things. And check out the specs here. So they actually give you quite a lot of information about kind of how the rooms and players and adv.py should work. So if you're ever kind of lost, you can take a look here. These are kind of the mandatory sort of attributes that you probably should have, but there isn't really anything that says you can't not be creative with different parameters and things like that. Cool. And so as you can see, it looks kind of wordy, but once you get past day one, day two becomes a lot more clear because your code is already structured in such a way where if you want to add items or add more parameters to rooms, all you have to do is go to the appropriate files, appropriate classes, and modify them. And hopefully that's sort of, we start to kind of see the power of object-oriented programming this way, because all of our sort of thought process is garnered by, okay, where should this information live and how should these classes interact with each other? Once we kind of know the answer to those questions, that's pretty much the planning step of our Lambda planning framework, our problem-solving framework over. And all we have to do is implement and decide whether or not that was the right approach. Okay, cool. So any last questions? Dustin, I see your questions. WebSockets in Python. And we could talk about, maybe we can talk more about that in the instructor hour or something, because I don't really know yet. Not as easy as JavaScript. It was good today. Thank you for asking, Dustin. I had a good day. Okay, yeah, thank you guys once again. I know there might have been quite a bit of information thrown at you, but never fear. Have fun with the adventure game. I will see you on Wednesday to kind of finish up talking about classes. We're going to talk more specifically about inheritance and composition and relationships between classes. And then we're probably going to, honestly, we're probably going to spend a little bit of time working on the adventure game. So try your best, get to day one MVP, and we're probably going to end up kind of getting through a couple of parts of the adventure game next on Wednesday, and on Thursday we have instructor hour for any questions regarding object-oriented programming, Python. Yeah, cool. I'm excited to see what kind of ideas you guys come up with. Yeah, awesome. Have fun. I will link this here now, but you should have it in your training kit as well. Okay, great. With that, have a good night, everyone, and I will see you on Wednesday. Yes, I'll share the code once I'm done this call. Awesome. Bye, everyone.